divided by the first element of the row. Okay? So, what condition must I have? So this is the root. What condition must I have to have closed loop stability? No sign change in the first column. Okay? Closed loop stability requires no sign change or 0 in the first column. So, what is array? Root array, exactly. Now, tau I, the integral time constant, is always positive. Okay? So since tau I is always positive, the first element is positive. Not to have a sign change, what is then required? Everything else must be positive. Exactly. Since the first element is positive, everything else must be positive. So that boils down to 2.99 tau I minus 0.07 kc tau I must be positive. Okay? Now, points at minus the determinant over 2.99 tau I minus 0.07 kc tau I must be positive, but we must have this positive, which is the denominator. So the denominator must be positive. For the ratio to be positive, what does that imply? The numerator has to be positive. Clear, everyone? Because row 2 requires that the denominator of row 3 must be positive. That means the numerator of row 3 must be positive. Sound clear? No? Look, this guy is positive, right? Because tau I is positive. So that means to have no sign change, everything must be positive. So second row gives us that this must be positive. Third row, the dot would have to be positive. The dot is minus the determinant over this. But what is this? That's exactly what I have in the second row, which must be positive. So since this must be positive, for the ratio to be positive, the numerator must be positive.
But the numerator is negative to cancel out the negative in front. Okay? Just like there's a negative in front.
No, the numerator is minus the determinant, whatever it is.
Oh.
What?
If it was negative 0.03 tau Y, then
everything would have to be negative.
Okay.
Look, you can rewrite this equation, multiply by minus 1.
This is subtract.
1.
Yeah.
Here. You can rewrite this equation by multiplying it by minus 1, right?
No, wait.
If something equals 0, minus something equals 0. Then I would have minus here, minus here, minus here, minus, and then everything would have to be negative.
Yeah.
Okay? So, it's really how you have written the equation. If this element is positive or negative. Sorry.
Good question. Is the negative sign, or is that minus? So the top row minus the bottom row, right?
No.
Minus on the top. Well, that's minus, but yeah, put it on the top. So, that means that minus the determinant has to be positive. So, since condition above means that minus the determinant must be positive. Okay?
good enough.
And the last condition is 7kc
You're not subtracting these two.
must be positive.
Take a determinant and then negative.
Okay, everyone? Felix? Now, notice here, tau I factors out. Yeah.
What's in the numerator?
I wrote it up there, I'll write it when I'm ready to use it.
Okay.
Okay? Notice here, tau I cancels out. Right? You can factor tau I, and because it's positive, canceling it out doesn't invert the inequality. If it was something negative, it would be inverting the inequality.
Huh. Didn't know that.
Huh?
I didn't know that.
These two minus
Okay. Minus 3 less than 0. If I cancel the minus, what does that make it? 3 bigger than 0. The inequality inverts. All right. So this becomes 2.99 minus 0.07 Kc positive. And from here, immediately follows that, okay, I write all the algebra, greater than 0.07 Kc. So Kc must be less than 2.99 over 0.07.
If you divide by negative, it flips the sign. It
Yes.
flips- That's the only okay.
Yes. Yes. If you divide an inequality by something negative, it flips the sign. All right. The last inequality also involves only Kc. I'm dividing with something positive, so Kc must be positive. So let me write I1 for inequality 1, I2 for inequality 2. You can combine the two inequalities, so we get immediately a condition on Kc that Kc must be positive and less than 299 over 7. That is beautiful numbers. Okay? So notice an incorrect Kc we have made the system, no matter what I do with tau I, unstable. So you have to pick a positive Kc, and I'll get back on the proper sign of Kc in a minute. Making question.
Why is it 7?
Because I had 2.99 over 0.07. So I wrote this 299 over 7.
Yeah, sorry.
Yeah. Oh, thanks for asking. All right. Now we have, I left the most difficult for last, but notice this involves tau I. So that means I have essentially one inequality to satisfy, and we have one parameter that I'm free to choose any way I want. So I can satisfy this inequality by picking appropriately tau I. So let's do that. So let's put this inequality 3. So that's inequality. Actually, let me rewrite that. Since I have a minus greater than 0, I can rewrite its determinant what? Less than 0. So let's call that inequality. So inequality 3 is so we want the determinant less than 0. What's the determinant? Product of diagonals minus product of off diagonals. So that's going to be 0.03.
So why did you write that one before? without doing using I3.
What did I, what?
You wrote that piece. I don't know what the I1 and I2.
Yeah,
Why'd you write that before figuring out what I3 was?
because I3 also involves KC, but we are okay on KC as long as we satisfy that.
It doesn't need I3.
That didn't need I3. We can get this conditional KC without I3. But I3 will give us the constraint on tau I. Mika.
For I2, why does the sign flip even though?
Because I divide by a negative number. What I showed you before.
Oh, no, but I don't.
If minus 3, okay, here's an inequality. Minus 3, is that greater or smaller than minus 5? It's greater than minus 5, right? So if I divide by minus, what happens? I get 3 and 5. How should the inequality be? Dividing by a negative number flips inequalities. Okay, listen.
Why does he multiply 7 KC?
Huh? Say again?
Why does he multiply 7 KC by a negative?
I didn't multiply 7 KC by anything. 7 KC because how much KC bigger here? That's a positive number I divided by. So the inequality stays the same.
I think she means like it used to be 0.07, now it's 7.
Oh! Was it? No, it's 7 KC. It's 7 KC, the fourth row.
Yeah, but you did here 299 over 7.
Oh, simply because instead of write
I know.
2.99 over 0.07, I wrote 299 over 7, guys. And I don't think that divides, right? I would be super sorry. 89 minus 9. All right. Okay, everyone? So, I have 0.03 tau I times KC, that's the product of diagonals, minus the product of off diagonals. So minus 2.99.
You're missing a 7.
Oh. I have to see it, man. Minus 2.99 minus, oh, tau I. Minus 0.07 KC tau I times minus tau I plus 7 KC tau I minus 0.07 KC. Must be now less than 0. What kind of equation is this on tau I? You can see tau I factors out here, I can factor it out. So, what kind of equation is this on tau I?
Cubic?
Polynomial.
Yeah, what degree?
Quadratic?
Quadratic. Right. This part has tau I to the first part, this part has tau I factoring out from here and tau I from here. So, let's write it in terms of what we have for tau I. So I have, let me incorporate that minus here. So I have 0.07 KC minus 2.99. And from here I have 7 KC minus 1. Tau I squared. Okay, these are the tau I squared if I didn't mess up. Hopefully. And then first order for tau I have from here, okay, let's multiply the 7, so that's 0.21 kc. And from here, tau I terms are so I have a minus 0.07 kc times, the minuses, I will not forget that. So hopefully I don't mess it up. It's a little bit, be careful. I'll tell you what, let me erase the tau I and put the tau I here. So I'm factoring out the tau I
I don't have white out.
to make it a little bit easier. Okay. So,
I mean, it's not going to change the final answer.
so the only quadratic was this 2 times that is the coefficient of the quadratic. Here, you can rewrite this as 7 kc minus 1 times tau, this part. So, the quadratic was this times that times minus 1, and this times minus 1 became this. First order. First order is the 0th order part of this with this. So it's going to be 0.07 kc, I'm taking care of the minus, times 2.99 minus 0.07 kc. Okay? Yeah. So that's the first order for tau. Finally, 0th order. What is my only 0th order? Oh, I don't have. Oh, guys, I was not very smart. I was stupid. There's a tau I cancellation. Unless I made a mistake in algebra, there's a tau I cancellation. I realized when I saw the other term. Tau I from this part and tau I from this part.
Uh-huh.
Cancel this part.
Even when you don't have a tau I here?
No, I have. This multiplies everything.
So there's no sign in between those parentheses?
Hmm? No, there's no sign. This is product. This is product. So this is first power, and this is 0th power, less than 0. So given any kc tau I should satisfy that. But if I want to write a strict inequality of tau I, have to be careful. If this is positive, and okay, we can immediately write, we can write this. We can write a 0.07 kc minus 2.99 times 7 kc minus 1 tau I. Moving this to the other side must be less than minus 0.21 kc minus 2.99 times 0.07 kc, which is, okay, I should have left it 0.07 times 3. That's 0.07 times 3. So subtracting 0.07 times 2.99 makes 0.07 times 0.01. Okay? So that would have given me, all right, here. I'll confuse everything so you can see. So minus, someone with a calculator, 2.99 times 0.07. Plus, that's a plus. No.